This video will cover the microscopic anatomy for all of our different tissue types here. So we're going to go over the 3 types of cartilage and then the 2 types of bone. So here we have hyaline cartilage. Now when you see this under a microscope on the practical, you should be expected to possibly be asked not only about the structure or identifying it as hyaline cartilage, but also the function and the location of hyaline cartilage. So if we look here, we can see out in the extracellular matrix here, it looks very glossy and in appearance, and you can't really see much going on out there. What you do see here is the chondrocytes, so here's the chondrocytes, the little dots there, within their lacunae. And the location of hyaline, a very good location example is the articulating surfaces of long bones. So hyaline's got this very smooth appearance to it, and that's because it is smooth. It reduces the friction at the ends of articulating surfaces of long bones. So here's another picture of hyaline. It's just stained a little bit differently. It's blue. But again, we don't see very much going on in the extracellular matrix. Here we can see our chondrocytes within our lacunae. And then we have elastic cartilage. So the same thing applies for elastic cartilage. You have to be able to identify it as elastic cartilage. So the way that we can do that is only with elastic cartilage we have elastin fibers out in the extracellular matrix. So those are those dark purple fibers that we see that we did not see here in the hyaline, right? So there's no dark purple fibers in the hyaline cartilage because only collagen is found in the extracellular matrix of hyaline. Both collagen and elastin are found in the extracellular matrix of elastic cartilage. But again, we see the same overall structure where we have the chondrocytes inside the lacunae. Here's another possible one that you could see for elastic cartilage, just from a different location. And we can still see those dark purple strands. They're not as abundant as the previous picture, but you can still see that the elastic strands are out there. And again, we have chondrocytes within our lacunae. Then our 3rd type of cartilage, we have fibrocartilage. So our fibrocartilage is really going to be very unique in appearance. We have thick, wavy bundles of collagen out in the extracellular matrix. And then we have to zoom up really close here. We can see a chondrocyte inside the lacunae. So you'll notice that the fibers out here are very dense, and there's fewer cells in the fibrocartilage. So this is what you would see on the practical, those thick wavy bundles of collagen in the extracellular matrix, and then here and there we have a chondrocyte within the lacunae. So the location of fibrocartilage will be found at our intervertebral discs, as well as our pubic symphysis, and its function is to prevent compression, so it provides tensile strength. Elastic cartilage, I like to say it can be found in our E3 locations, so our ear, our eustachian tube, and our epiglottis. And its function is to provide elasticity to the structures. So here we have spongy bone. The structures you need to know for spongy bone, so the lamellae, which is just termed, which is the term for our bone extracellular matrix. The lamellae is organized into what we call trabeculae. So this little network of pink here, all this is bony tissue, and we call that trabeculae. So this is in contrast to compact bone, where we find the lamellae are organized into concentric rings to create an osteon. So over here, our lamellae just literally looks like a sponge. So the spongy bone, the lamellae is organized into trabeculae, and there's that word. So other than that, at a higher magnification, you will be able to see the osteocytes inside the lacunae in this region of the bone. And then remember, spongy bone is the location for red bone marrow. So out in the little spaces between the trabeculae, we find our red bone marrow. Okay, so that one's they're going to be dark little specks that are representing all the blood cells, the precursors to the blood cells. So the location of spongy bone would be the epiphyses of your long bones, also in the middle of your flat bones like your skull. Its function is in hematopoiesis, which is the production of red and white blood cells. So in our bone marrow, our red bone marrow, that's where we are producing our blood cells. That process is called hematopoiesis. Then we have compact bone. So remember, compact bone, the lamellae is organized into concentric rings to create osteons, and then many osteons come together to make up the compact bone. Here in the middle of each osteon we find a central canal, and that's going to be carrying blood vessels and nerves into the bone. Then if we take a closer look, we can see here are an osteocyte within its lacunae. And then once we get into a higher magnification, so here we can only see a single osteon in the picture. So when we're in this higher magnification, I will more than likely be asking about the canaliculi with the pseudopods running through them. So remember, we said the canaliculi are the tiny canals that run from one lacunae to the next, and the osteocytes send out pseudopods so that way nutrients and gases and waste can be diffused through those cells. And finally, they'll end up going into our central canal and dumped into the bloodstream. Then our locations for compact bone, that's going to be the diaphysis of the long bones as well as the outer surfaces of your flat bones. Its function is to provide strength to the bone.